The Earth's internal structure is divided into several layers that differ in composition, density, temperature, and physical properties. Understanding these layers helps scientists explain natural processes such as volcanic activity, earthquakes, and plate tectonics. The Earth's structure is studied through seismic waves, rock samples, and geophysical methods. Major layers of the Earth. The Earth consists of three main layers. 1. Crust. 2. Mantle. 3. Core. Each layer is separated by boundaries known as discontinuities, where seismic wave behavior changes suddenly. A. Crust. Definition: the outermost solid layer of the Earth where we live. Thickness: continental crust, 30-70 kilometers thick. Oceanic crust, 5-10 kilometers thick. Composition: continental crust, mainly granite, sial, silica and aluminum. Oceanic crust, mainly basalt, sima, silica, and magnesium. Temperature ranges from 0 degrees at the surface to about 400 degrees at the base. Important discontinuity: Mohorovičić discontinuity, moho, the boundary between the crust and the mantle, discovered by Andrea Mohorovičić in 1909, marks a sudden increase in the velocity of seismic waves. B. Mantle definition: the thick middle layer located beneath the crust, making up about 84% of Earth's volume. Depth: from about 30 km to 2,900 km below the surface. Composition: rich in silicate minerals such as olivine, pyroxene, iron, and magnesium. Temperature increases from about 500 degrees Celsius near the upper mantle to 4,000 degrees Celsius at the lower mantle. Divisions: 1. Upper mantle, 3,560 kilometers, includes a semi-molten zone called the asthenosphere, where rocks are partially molten and allow plate movement. 2. Lower mantle, 660, 2,900 kilometers, composed of dense, solid rock under high pressure. Important discontinuity: Ripetti discontinuity, between the upper and lower mantle. Gutenberg. Discontinuity, between the mantle and the core. C. Core. Definition: the innermost layer of the Earth, mainly composed of iron, Fe, and nickel, Ni, often called the knife layer. Depth extends from 2,900 kilometers to 6,371 km, the center of the Earth. Temperature: extremely hot, ranging from 4,000 degrees to about 6,500 degrees at the center. Divisions: 1. Outer core, 2,900 to 5,150 km. State: liquid. Composition: molten iron and nickel. Importance: movement of molten metals generates the Earth's magnetic field. 2. Inner core, 5,150 to 6,371 km. State: solid, due to immense pressure. Composition: mostly solid iron and nickel. Important discontinuity: Lehmann discontinuity, boundary between the outer core and inner core, discovered by Inge Lehmann in 1936. 2. Summary of Earth's layers. Layer depth, approx. State temperature range, DGC. Main composition: discontinuity crust, 0, 30-70 km solid 0, 400 degrees C, silica, aluminum, magnesium. Moho discontinuity, upper mantle, 30, 660 km solid semi-molten 500, 1,500 degrees C. Silicate minerals, Ripetti discontinuity lower mantle, 660, 2,900 km solid, 1,500, 4,000 degrees C. Iron and magnesium silicates Gutenberg discontinuity outer core, 2,900, 5,150 kcal liquid, 4,000, 5,000 degrees C. Molten iron and nickel, Lehmann discontinuity. Inner core, 5,350, 6,371 km solid, 5,000, 6,500 degrees Celsius, solid iron and nickel. 3. Discontinuities in Earth's interior. Discontinuities are boundaries where seismic waves suddenly change speed or direction due to variations in material density or composition. Name between nature of change: Mohorovičić, moho, crust and mantle. Change from basaltic chalk granitic to denser peridotite, rock. Ripetti upper and lower mantle variation in mineral composition and density. Gutenberg mantle and outer core change, from solid silicate to liquid iron nickel. Lehmann outer core and inner core change from liquid to solid state. The Earth's internal structure is a complex system of layers that differ in composition, temperature, and physical state. The crust forms the outer shell, the mantle drives plate movements, and the core generates the magnetic field. The study of these layers and their discontinuities helps scientists understand the dynamic nature of our planet, including earthquakes, volcanoes, and continental drift.